Okay. So last year we had done the capacity building initiative from the part of Journal of Psychiatry Spectrum, wherein we had seen the statistic webinar series. And currently in this year, we are focusing more on manuscript reading, writing, and reviewing. So till now, we have completed our title abstract, introduction, results. We are still remaining with discussion. So today's topic is one of the most important ones, wherein we would try to learn on how to present the statistical tests within the results section. So for that, we have, of course, it's an honor for us to have Dr. Mariyamma Philip, who is professor from Department of Biostatistics at NIMHANS. And today's session is going to be moderated by Dr. Subhashini, who's associate professor in the Department of Psychiatry in Saveetha Medical College, Chennai, who's also an associate editor at Journal of Psychiatry Spectrum. So before we go ahead with today's session, I would first request Dr. Anil, President IPS KC, to give a few opening words.
Good evening, all, and welcome you all for this sixth episode of a webinar series on how to write a paper. So, as mentioned, we have covered most of the key areas, and however, today's topic is special, especially in the background of statistics being considered as enigmatic by many, if not many, at least some of us. So it's just not to do with the content of a table, but how to represent the content. With the statistics in the perspective is what is important. And I sincerely thank the resource persons, Dr. Mariyamma Philip and Dr. Subhashini, who have accepted our invitation to be the presenter and moderator today. And in fact, both are active in our own journal. So I hope you all will I wish you all will have an enriching experience today with their knowledge. I request Dr. Apurva to take over for further proceedings. Thank you.
Thank you, sir. I now request our honorary editor, Dr. Vijay, to give a few remarks for today's session.
On behalf of IPS KC and the journal team, I welcome you all. This is very important topic because I get a lot of submissions, but the exact statistics, even when I'm sending it to the reviewer, even I don't know how much the reviewer is able to understand and what can they look at, and then what they can suggest changes and things. Then as editor, I would be worried whether the reviewer has actually gone in detail, in depth of these statistics. I'm not sure. So we do have three statistics consultants in our journal team. Fortunately, for the last almost like 2.5 years now. So that has improved our quality. However, it's important that we all should know when we are writing how to present. We do a lot of analysis in our SPSS, but how to move that into the Word document. We don't know how much to and what are the things that are needed to present. So I think without wasting much time, I back to Apurva.
Thank you, sir. I now request the chief coordinator for this online academic series, Dr. Ravindra Monoli, to give some remarks and introduce our moderator for today.
Yes, thank you, Dr. Apurva. And I think most of them have talked about like what exactly it is about and all how we are proceeding. I'd like to read the moderator's name. Okay, so it's an honor for us to have Dr. Subhashini K as today's moderator. Dr. Subhashini has completed MBBS from IIT Perantara Medical College, completed MD Psychiatry from Madurai Medical College, subsequently cleared DNB and fellowship in psychiatric rehabilitation and PhD in clinical neurosciences from NIMHANS, Bengaluru. As it was mentioned, she is an associate editor of our own Journal of Psychiatry Spectrum. Also a reputed peer reviewer in BMC Geriatrics, Frontiers in Aging Neuroscience, Journal of Psychiatry Spectrum, Archives of Mental Health. Ma'am's areas of interest include neuropsychiatry, CLP, geriatric psychiatry, mental health rehabilitation, and neurocognitive disorders. With vast experience and an avid contributor and a supporter of our journal, we welcome you, ma'am. Over to Dr. Apurva.
Thank you, sir. I now request our moderator, Dr. Subhashini, to please take over for today's session.
Thank you, sir, for that kind introduction. And thank you, Dr. Apurva. Mm. So, uh, I would like to introduce our speaker, Professor Dr. Mariyamma Philip, ma'am. So, ma'am has completed her MSc in Biostatistics and also her PhD in Biostatistics from both from very reputed institutes, and she has an experience spanning 28 years. And her areas of interest include regression modeling, artificial neural networks, incomplete data analysis, and rating scale construction. So personally also, ma'am has guided me a lot from the initiation of my PhD protocol till the end, and a lot of guidance during my PhD coursework and during the workshops. And also, it's an honor to be a moderator for the session, which where ma'am is the speaker. So, I'm excited to hear from you and obtain insights about how to present the statistical data and tables and figures.
Thank you, Subhashini, for that warm welcome. Thank you, IPSKC, also for giving me this opportunity, especially Dr. Vijay, Dr. Ravindra, and Dr. Anil. And I'll just share my slide. Is the slide visible for everyone?
Yes, ma'am, it's visible.
Yes, ma'am. Okay. Okay. So before we move into any of the other, they say like the statistical test or anything like that, the first and foremost important thing what we need to do even before we analyze is we need to check for the data quality and the quantity. When you say quantity, whether say suppose we are going to compare between two groups, do we have enough number of subjects in each of the groups to make the comparison, or whether the data is highly skewed in one group, majority of the subjects are in one group. So whether first of all we need to do the test at all, that also need to be decided first. And then we need to think about the number of variables in the data, the number of tests what we are going to do. Nowadays, many of the journals are reviewers are asking about this multiplicity issue. So if you have too many parameters, generally we collect all data, whatever is possible, right? And then we also try to analyze all of them. So multiplicity issue, if you have multiple variables correlated or compared between the group, too many than the number of subjects you have, then multiplicity issue can arise. And most importantly, whenever any data is analyzed, before doing any test, we need to check the assumptions of the test. So when you talk about the assumptions, the most important usually is normality. And when you check the normality assumptions, we don't have to give the normality test results in SPSS. Generally, we just give a sentence like what I have written on the slide. Normality was assessed, and so variables were found to be non-normal. You don't have to list out all the variables that were not normal. So just mention, like, depending on what is majority. If majority are normal, then mention the non-normal one, or vice versa. And appropriate statistical tests were used to analyze these variables, or you can even elaborate. For these variables, we have used non-parametric test. For these, we have used parametric test, like that. Then when it comes to comparison of means between groups, we have this equality of variance assumption. Again, that is part of the test in SPSS. In some journals like R and JAMOVI, you need to do the test separately, whether the variances are equal or not, and then you go into t-test or ANOVA. So again, that table need not be presented. You can just write the result either in the text or as a footnote of the table. As we go to t-test and ANOVA, you will be able to see how I have added that in the footnote. Similarly, when you do a general linear model, repeated measures analysis, we have mostly tests to test the assumption of sphericity. Again, if that is not met, greenhouse geyser correction has to be made. That also need to be mentioned either in the text or as a footnote. When it comes to regression analysis, we need to be very careful because the assumptions of regression, you can check only after running a regression analysis. So that's why we call it as regression diagnostics. So once you run a regression analysis, Only after completing the analysis, you will see whether the residuals are normally distributed, there is equal variance, the homoscedasticity assumption, multicollinearity assumption, and when it is a logistic regression, again, the number. If the data, the two groups are highly skewed, then your results are going to be biased. If there is interrelationship between the variables, your confidence interval of the odds ratio would be very wide, sometimes non-estimable if unequal numbers are there. So these are some facts we need to think even before we do the test, or even before we come into the presentation of results. Now, my slides, how I have arranged is from the common or from the basic to the advanced. I have included only till logistic regression. From showing you a data as an example, and then generating some research questions, showing you the SPSS output, and then how to make the table from that output. So this is the data, original data, slightly modified. So you might not get any things what you expect, because the data structure is the same, but the data inside this is completely simulated by the computer. So that it is not, I'm not misusing somebody's data which is given for analysis. So this study is effect of yoga to see how it affects the depression and anxiety. As you can see here, we have two groups, yoga and non-yoga group. We have age of the patient, gender, education, and anxiety. Anxiety categorized, depression categorized. Similarly, anxiety and depression again at the post level. So as I mentioned, this is now slightly modified data or simulated data. So you might not be able to get a logical results when you are doing some comparisons. So my first research question here is, are the scores of anxiety and depression similar between the two groups at the baseline? So anxiety and depression are two numerical variables, and group is a binary variable because it has got two categories, yoga and non-yoga. So here I am intending to do a comparison of numerical variables between two independent groups. So I'll be using independent sample t-test. These are the assumptions of independent sample t-test. I am not talking about normality here. But why is this equality of variance assumption important? Recently, a paper which I have reviewed, I think even in the IPS, Journal of Psychiatry Spectrum, even after this was suggested that the equality of variance assumption should be checked, they were telling that that is a limitation of the study. That can never be the limitation of the study. This can be tested. Lesser sample size can be a limitation of the study, but we have not checked the assumption of equality of variance cannot be a limitation of the study. If you have the data, it can be checked at any time. So why is it important? It is important because if the dispersion or the variation is so, if similar, means can be directly compared, as you can see from the picture. But if the variation is different, we cannot directly compare the mean. Our comparisons might not be very meaningful. So we need to make some correction for the comparison. Pictorially, this will be like this. Two groups, means are same, but variations are different, right? So just because they had the same mean, we cannot say that data is similar or the distribution is similar. Variation still could be different. So we need to adjust for the unequal variance when you are comparing the mean values. So this is the result of a t-test. I have deleted some part of the output, and generally we get two tables. And the latest versions of SPSS gives one more table, that is the effect size table. So initially it will be very confusing for people who are doing it or seeing it for the first time. So what we can do is, I have just highlighted different headings in different colors. So when you look at the second table, that is the independent sample test table, the first part is the comparison of variance, equality of variance. And then the second part is t-test for equality of means. Again, more information like mean difference, standard error, more information are there. I have deleted because we need only this. And what are we trying to do? We are going to compare the anxiety between the mean anxiety between yoga and non-yoga group. But before that, we need to ensure the assumption of equality of variance is met. So first we'll be comparing the standard deviations here. Okay, that is done using a test called Levens test for equality of variance. And we can see the p-value here is 0.545. And all of us know that a p-value less than 0.05 is considered significant. So since this is greater than 0.05, we conclude that variance of anxiety do not differ significantly between groups. Please look at the mean values. It is 3.6 and 4.5. They are different, but they are not significantly different between the groups. So what does that mean? It means that equal variance can be assumed. All of you are with me? So then now we can go ahead with the t-test. Okay, that is for the comparison of the anxiety score between the two groups. So we look at the t-test result for that, t-value, degrees of freedom, and the p-value. This p-value is also greater than 0.05. So we conclude that the average anxiety score do not differ significantly between the groups. So now we'll go on to the depression, second variable depression. 7 and 3 are the standard deviations. We will look at the Levens test result. P-value is 0.028. That is less than 0.05. So we conclude that the variance of depression score differs significantly between the two groups. That means we cannot assume equal variance. There is a difference in the standard deviation. So this fact has to be considered when we are comparing the mean scores between the two groups. Is that clear? Equal variance not assumed. So now we'll go ahead for the t-test. Look at the t-value, degrees of freedom, and the p-value. Now, as you can see here, the degrees of freedom is not 38 here. It is slightly different. That is the correction that is done for the comparison of means. The degrees of freedom is adjusted for the unequal standard deviation. More details will be difficult for a non-statistician to understand. So I'm not attempting that. The p-value here is 0.165. So this is again greater than 0.05. So we conclude the average depression score do not differ significantly between the groups. So now this information, what we get as two different tables. Effect size table I have not shown you. So we need to put them into a table which can be used in our thesis or in our manuscript. Now, when you make a table, there are different format, like APA has a certain format. I'm just showing you a general format of preparing this result. Now, before that, the equal variance assumed t-test is what we call a student t-test. If equal variance is not assumed, a slight variation of the t-test is done, and it is called as Welsh test or Welsh t-test. So we will try to put the table here. The title will come as table comparison of parameters between the study group. And this will be the basic structure of the table. Variables in one column, and the two groups will come as two different columns, and then you have the t-value and the p-value. So we'll try to fill in the variables, enter the mean and its standard deviation from the first table, that is a descriptive statistics, and enter the t-value and p-value from the second table. Now we can, as I mentioned earlier, the assumptions and equality of variance, we can either give it in the text or we can give it as a footnote. So here I have given a footnote, and I've given at the rate as a symbol near the depression score, and footnote is added to indicate that for depression it was a Welch t-test. You don't have to give that for anxiety it is independent sample t-test, because just before your table you will be writing a brief description that you have done independent sample t-test to compare these variables between the two groups. So you don't have to add so many legends and create more confusion, or don't make the table very crowded. In addition, we can also add the effect size. This will be Cohen's d. Most of the softwares automatically give the effect size here. That will also be an indication about how strong the difference was or how big the difference was. Magnitude of the effect is what the effect size gives. So we can attach the effect size. Now, degrees of freedom, we don't have to mention here because in the title we have mentioned the number of subjects in each group. So we know for sure the degrees of freedom will be 28 in each group, 29 in each of the groups. So the degrees of freedom is 58. We should be able to understand that. And Cohen's d has cut off like 0.2, 0.5 and 0.8 for small, medium and large. Suppose now the scores, that is the anxiety and the depression, were not normally distributed, either in one of the groups or in both the groups. If it is not following normal distribution, we will not be able to use independent sample t-test. We'll have to use a non-parametric equivalent called as Mann-Whitney U-test. So Mann-Whitney U-test will not have any descriptive statistics. It will, if there is an option, but in SPSS, it will give you the values for the entire group, not separately for each of the group. It will give you a summary table like this, which will have the p-values directly. And it will also give you the latest versions, or depending on the type of test that you are choosing, you will also get more details about each of the variables. So for anxiety, we have the Mann-Whitney U value, Wilcox and W. So many things are there. We don't have to worry about that now. So we get the p-value here. And also the good thing about the non-parametric test is that we are able to see the decision as the last column here, whether retain the null hypothesis, accept the null hypothesis, it will be written there. So it is easier for a non-statistician to understand the results. So when retaining the null hypothesis means that there is no difference between the two groups. Anxiety and depression do not differ significantly between the groups. So when we have to report the findings, we need some descriptive statistics. When you say non-parametric test, there is no parameter, and mean will not be an ideal measure of central tendency when the data is not normally distributed. So we'll have to request statistics, descriptive statistics for both the groups separately. Now in this table, as you can see here, I have mean, standard deviation, minimum, maximum, and the percentile score, 25th percentile, 50th percentile, and 75th percentile for yoga and non-yoga group, for both anxiety and depression. What I've highlighted is the percentile because that is what generally we represent when you are doing a non-parametric test. So we'll see the table format of Mann-Whitney U-test now. Title remains the same, comparison of parameters or variables between the study group. Everything remains the same except that instead of mean standard deviation, we will be reporting median and interquartile range. And instead of t value, you will be reporting a u value. Now, what is this interquartile range? Interquartile range is the difference between third quartile and first quartile, or 75th percentile and 25th percentile. Now, it can also be written as, I have written here 25th percentile, comma, 75th percentile. It can also be written as 75th, comma, 25th. 25th, 75th, 75th, 75th. 75th, 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 75 Some people, instead of writing interquartile range, they write the range in the bracket, that is minimum, hyphen, maximum. This is the way. So when you look at these two tables, can you see the difference? The median for anxiety in the non-yoga group is 9. The lowest score is 5. The largest or the maximum value is 16. 25% of the people have values up to 6. And then the midpoint is 9, that is a median. 50% of the subjects had an anxiety score of 9 or lesser. And 16 is the 75th percentile. So it means that 75% of the subjects in the study had a score of 16 or lesser. That means the remaining 25 have above 16. So you are able to, 13.25. I'm sorry. 13.25 is the Q3, 75th percentile. So 75% of the subjects have a score of 13 or lesser. That means the remaining 25% have the scores above 13 up to 16. So minimum, maximum, and if you are able to divide the data into 4 equal parts, Q1, Q2, Q3, and Q4. Q1 is 25th percentile, Q2 is median, 50th percentile, and Q3 is 75th percentile, and Q4 will be the 100th percentile, that is the maximum value. Any doubts anyone has? Should we clarify and go?
Ma'am, degrees of freedom for this one? Any degrees of freedom for this one?
There will not be any degrees of freedom because we are not estimating any parameters in a non-parametric test. Degrees of freedom will come only for the parametric test.
Yeah. Just from editor's perspective, we usually want people to write N in small letters for subgroups.
Yeah, that is okay. Yeah, that is fine. That is up to you. Yeah, small and it can be written.
Capital N is equal to 60 on top.
Yeah.
Comparison between the bracket. That's from editor's perspective. So sorry.
Okay. So U value can be obtained from the table, and P value also can be written.
And which one do you recommend? IQR or range? What do you recommend? Is superior?
Many statisticians prefer IQR, but medical researchers prefer range because they are easily able to understand the range. Quartile is little more difficult for people to understand. But the standard format we usually prefer is median and IQR. Because why we don't prefer range is because when do we go in for Mann-Whitney U-test? Because the data is skewed. If there is skewness, the lower end will have the skewness, elongated tails. The lower value and the higher value will be affected by that. That is why 25th percentile and 75th percentile is used.
And it is usually comma, not hyphen, comma for IQR.
Usually comma, but there is no hard and fast rule. You can even use it as comma. But only thing is that for all tables, you should use a uniform format, either comma or hyphen.
There is another question.
You want to take any question relevant to these?
So there is a question on the chat, sir. So someone, I am not able to see their name. They have asked, what is the importance of equal variance assumed?
Okay, yeah. Go back to that slide. So if when you look at the first picture here, if the variances are equal or the standard deviations or the variances are equal, mean can be directly compared. If the variances are different, we cannot directly compare the means. Some correction has to be made, right? So that is why it is important. So when you compare between two groups, say for example, when you look at the two groups, when you look at the mean value, we might say that they both are similar. But when you look at the data points, individual data points, I might say that this yellow color curve group, that group is better because they have less variation. Say, for example, if these are the marks of students in a class where everybody's score is between 50 to 70, whereas the black color curve is a group of students where the range is from 0 to 100. There are people who are failing in the class as well as people who are getting full marks. So teaching to such a class will be very difficult for the teacher because there is so much of variation. Whereas the other class, everybody are in the say around 50 to 70. Teaching their reception levels are similar. Teaching would be easier. So when you compare the mean value, mean could be similar because of there are some people who scored 100. Because of that, in the other group also, the mean value will become equal. But are they similar? We cannot say whether they are similar or not. So for the comparison, we need to assume that the variation is similar, so means can be directly compared. If variations are different, correction has to be done or adjustment has to be done for that. That is why we use the Welsh t-test. Is that clear?
Is your doubt cleared? Because I'm me. If it's not clear, probably you can unmute yourself and get it clarified.
Yeah.
Ma'am, actually, I had a doubt, ma'am.
Yeah.
Ma'am, when we are using, I mean, like the student t-test or the Welsh's test, so there is a variation in the degree of freedom, no, ma'am.
Yes.
So is it necessary to, I mean, like during the presentation you mentioned like it's not mandatory to mention the degrees of freedom.
Yeah.
But
We don't have to give
because
the degrees of freedom. We know how much will be the degrees of freedom when there is unequal variance. That also will be same. But when since you are mentioning the numbers here, we don't have to give the degrees of freedom. And we are mentioning here that we have done the Welsh test. So degrees of freedom for that will be slightly different. If you have 60, we know how the degrees of freedom would be. It cannot be different for different variables.
okay.
So you don't have to give the degrees of freedom. There is no harm, but it is the value will be same for all parameters. So it is better instead of repeating the same value in all the rows, when we are having multiple variables, it is better to avoid the degrees of freedom.
Okay.
Ma'am, are we supposed to give, or do you recommend us to give mean value also along with median, or you just say from the test of normality?
Ideally speaking, median and IQR is enough. But we are also used to seeing mean and SD. So some people also give mean and SD along with that. But I would say if you are giving mean and SD, it should be below median and IQR. First row should be median and IQR. Next row can be mean and SD.
So strictly technically, this is correct.
This is what is needed. Yeah. But there is no harm if you give mean and SD, but the comparison is based on median and IQR. Once you give mean and SD, your table will become little more crowded because you will have one more row in each of the cell. Say for anxiety, I put 9 in bracket 6, 13.25. Next line, I will also find out the mean value plus or minus SD. Similarly for all the other cells. So the tables are going to be little more bigger when you add the mean and SD. There is no harm.
While we are on this slide, do
Yes.
you want to suggest on the decimal places, ma'am? Total number of decimal places, would you suggest anything in
Generally,
particular?
two decimal points for all except p-value. P-value, 3 decimal points. All other things, 2 decimal points. And again, U-value, Mann-Whitney U-value sometimes will be very, very huge. You will get it in 40,000, maybe 4 digits and all that. So there we can restrict to 1 decimal so that overall that column will not become very big. Okay, so for a Mann-Whitney U, we will not automatically get the p-values directly from the software. We will have to calculate the effect sizes. Sorry, what did I say? Not the p-values, effect sizes. So we'll have to use a rank by serial correlation coefficient as the effect size of Mann-Whitney U test, which can be easily calculated using a formula like this. R is equal to Z by square root of N. Now, what is a Z? Z is a standardized test statistic. I mentioned earlier in the previous slide that we will get more detailed results of the data from the Mann-Whitney U test. So here we have the standardized test statistic value. This is IZ. And we also have the number here, 60 as a total number. So we can substitute and then calculate the R value. And we can enter the values here. The cutoff is again 0.1 is small, 0.3 is median, and 0.5 is large. If you have too many variables for which we have to use the effect size, then we can use an Excel sheet. We can use an Excel sheet where, as you can see here, I put anxiety and depression as two different columns, and Z, N, and the third column is R. We can use a formula here. So 3 columns I have created. Z values are entered, the N is entered, and then I used a formula here that is Z divided by square root of C2, that is B2, column B, second row, that is B2, divided by square root of C2, that is again 60 here. It will create a value for the effect size. Now we have this small box here. We can just drag it. The formula will be copied for the other cells down, and all the effect sizes you can easily calculate using an Excel sheet itself. Is that clear for everyone? We know the formula is R is equal to Z by square root of N. The Z values we will get from the SPSS outputs. So we just have to enter that into an Excel sheet as one column. First column will be the parameters or the variable names. Z values can be entered, and then the number of subjects can be entered. And then we can use the equation, or we call this as function. No? Just type in the formula equal to that. When it comes to the column D, in the second row, you just type it as equal to B2 divided by, in bracket, square root of C2. It will create the value, calculate and give you the value. Just pull down this small square box down. It will fill the values for the other parameters also. You will be able to get the effect sizes. So with that, we will go to the next text, that is analysis of variance. So I want to see whether the anxiety and depression score differ according to education. So here anxiety and depression are numerical in nature. Education is categorical. It has got more than 2 categories. So it is a comparison of numerical variables between several groups. So the test is analysis of variance. The assumptions are similar as that of t-test. Yeah, for effect sizes, we can present the 95% confidence intervals also. SPSS also gives the 95% confidence interval. If your table is not very cumbersome or not very sparse, then you should be able to put the confidence interval also. So when you do the analysis of variance again, the first table will be a descriptive statistics. We have to request for the equality of variance test in SPSS. Automatically it will not come. Automatically even the descriptive statistics won't come. We'll have to see. Sorry. And this is a test of homogeneity of variance. So for anxiety, we are looking at the standard deviations. and we look at the p-values, and the conclusion is that the variants of anxiety do not differ significantly between the three groups here. So we can directly compare the means using analysis of variance. The conclusion from ANOVA is that anxiety differs significantly among the education categories. Okay, now we look into the next, depression. We look into the homogeneity of variance. The p-value is less than 0.05. Conclusion is that the depression scores, standard deviations are different among the groups. We can look at the values 2.94, 4.4, 4.8, and then 3. There's a difference among the three standard deviations that has to be adjusted. So we will be going into Welsh t-test for the comparison of means of depression, Welsh, and the p-value. Again, here the degrees of freedom is adjusted. Degree DF2 is different, right? So here the conclusion from here is that average depression scores do not differ significantly with respect to the group. How do we put that into a table? Before that, do we need to do a post-hoc test here?
Yes, ma'am. For
Anxiety,
value less than.
yeah, anxiety differs significantly. So we need to find out where is the difference. So we have to do a post-hoc test. So to do post-hoc test, again, when you go into SPSS, it has got two sessions. One where equal variances are assumed, and the other session where equal variances are not assumed. So here for anxiety, was there equal variance? Yes, variance of anxiety did not differ, right? The p-value was 0.148. So we can select the Bonferroni test from here and do the post-hoc test. So once you do the post-hoc test, you will get a table like this. Can you see the variable name anywhere? This is where the variable names will be here. Test name is written here. I've highlighted here as Bonferroni. So each of the categories, we had three categories. No formal education. I'll just show you the mean value here. No formal education up to 12th and degree or higher was the education of the patient. And these were the mean values, 8.13, 11.43, and 8.59. So what are we trying to compare? Group 1 with 2, Group 1 with 3, and Group 2 with 3. Can you see that from here, from the postdoc? No formal education, that is Group 1, compared with Group 2 and 3. Then Group 2 is compared with Group 3. And can you see that there will be a star next to the mean difference? Indicate that the two groups are different. Okay, this is called Bonferroni correction, Bonferroni test. That you can call this as a pairwise comparison, multiple comparison, or a post-hoc test. Post-hoc because after the global test of ANOVA, we do the pairwise comparison, or this we do as a post-hoc analysis. So now what is our conclusion? Group 1 and Group 2, Group 3 are different from what is common here. No formal education up to 12th, there is a difference. Up to 12th and degree and higher, there is a difference. What is common here is up to 12th. As if you can look at the mean value, what I highlighted here, 11.43 is significantly different compared to the other two groups. Okay, we'll see how we present the findings now. Comparison of parameters with respect to education. As you can see here, education of the patient, we have got three categories, mean and SD. And for the two variables, we will be presenting the mean and SD here, F value, P value, and we have the effect size. So we'll come back to the effect size later. That for anxiety, there is a significant difference. Can you see that I have given a star next to the p-value? And I'm giving that in the footnote. star means it is significant. And for depression, it was a Welsh test. So that is also given in the footnote. Now, how do we represent the pairwise comparison results? Right? We had the pairwise comparison results here. This table, how do we put this table into the results? Should we put this as a table? We'll just see. So I can add one legend here, one superscript here, hash symbol, dollar sign, hash symbol, and I can add here significantly higher anxiety compared to other categories. Shall I go back to the previous slide? We have seen here this 11.43 was the one which is significantly different compared to other two categories. So when I'm using the symbols here, I don't have to put too many symbols. I just have to put one symbol here, hash symbol, and then I'm saying that that particular value, that particular group had significantly higher anxiety compared to other two categories. Is that clear?
How about superscript A, B, C, A or
That is
B
also fine.
under
Yeah,
p-value,
instead of,
p-value?
yes, under
Superscript for p at the for p-value, superscript A, B, A and C in this case.
yeah, that is also possible.
A would be
That is also
comparison
possible.
between first and second. A and B, I think.
Yeah, I will show you that. I will show you that. So this is one way, but some people find it very difficult to understand this. Okay, here it is. It means that 11.43 is different than 8.13. 11.43 is also different than 8.19. You are mentioning only one symbol here and then explaining it here. So wherever you have similar kind of difference, you can follow the same symbol for depression. If there is a difference, we will be doing that. Other way of putting it is adding instead of giving this symbol here, hash symbol here, you can add one more column as pairwise comparison, and let's say 1 to 2 star to indicate significant, 2 to 3 there is a difference, 1 to 3 there is no significance. Because some reviewers, if some, it is actually sufficient if you mention only the significant pairs, pairwise comparison, 1 to 2 significant, 2 to 3 is significant. So we know 2 is the one which is a common factor. Both 1 and 3 are different from 2, the second group. That is what exactly what we have mentioned here. As this thing. But some people want all the results to be presented. So in that case, you can use this, the last column as a pairwise comparison result. All results are put. Now, why have not I given anything for depression? Mainly because the p-value is not significant. So there is no difference in the depression score among the groups. Okay. So education is not affecting anxiety. That's what, as I mentioned earlier, since this is a simulated data now, it might not be logical. You might not get logical results from the data here. So the anxiety scores are not significantly different among the categories. So there you don't have to do a pairwise comparison. Analysis of variance will have eta square as the effect size. Okay. And we have the cutoffs 0.01, 0.06 and 0.14 as the 3 cutoff. So here we have one large effect. Anxiety, the difference effect size is large because it is 0.142. Any doubts about analysis of variance? So if the data is not, tell me.
There was another question, follow-up question from Dr. Ranganath Kulkarni, ma'am. Like for in Man Whitney, how do we calculate the effect size for R?
For R.
Yes, ma'am. The
In
effect size.
R software.
95% confidence interval.
The confidence interval, ma'am. In
Confidence
Man
interval
Because,
will not be possible.
for R.
reviewers ask 95% confidence intervals for all the effect sizes.
Yes.
Okay. How do you calculate manually, or will it be available in the
Manually might be difficult for non-parametric test. It is not impossible, it will be difficult. I think it
do
is
we put
better
it
to
in the
use any
statistics software
software. Yeah,
and
any
output?
specific software that gives a 95% confidence interval you can use. Or Jamovi, I don't know whether it gives a 95% confidence interval.
SPSS. SPSS,
But
does it give?
effect size, actually, I have not seen many people using the confidence interval.
Okay.
Not very popular to use a confidence interval for effect size.
Okay.
It can be used as a standalone, as an independent value, but better to have the 95% confidence interval also.
Okay. Thank you.
So we'll move on to Kruskal-Wallis test. So again, as I mentioned earlier, if anxiety or depression are not normally distributed in any one of the groups or in all the groups, then we'll have to go in for a non-parametric test. So this is, as mentioned earlier, we'll get a summary table, and then we have a separate, more detailed results for anxiety, and then a pairwise comparison here. And the pairwise comparison, we also get an adjusted p-value, and the p-values have been corrected for Bonferroni correction. And then we get the results of depression. Here we get a footnote saying that the multiple comparisons are not performed because the overall test does not show a significant difference across the group. So we get these results, and we have to request for the descriptive statistics. Non-parametric test automatically will not give the descriptive statistics. We need to request for it. To reduce space, I have not shown mean and SD here. We can request for mean and standard deviation also, because the 3 groups, the table will become slightly longer. So I have removed the mean and standard deviation from here. So anxiety, the means are different. 9, 12, and 7, they are different. Depression, the scores are not significantly different. We'll put it into a table of this format. The format is same, except that median and IQR is presented instead of mean and standard deviation. And I'll just go back to this table once more. Here you see as test statistic. You don't get a value as H value or anything like that. So, but in the table, I have put it as H value. There is no harm if you put it as test statistic also. Okay, Kruskal-Wallis gives an H value. But if you are not sure if it is H value, you can even directly put it as test statistic. And P values are presented. Star is given to indicate the significant ones. And to indicate the multiple comparison test, I have again used the same format here, hash symbol, and the explanation here. The other way is to do a separate column indicating where the difference is. How do we get the effect size for Kruskal-Wallis test? Latest versions of SPSS automatically give the effect sizes for some test. If it is not there, we can calculate it using this formula. H minus K minus 1 divided by N minus K. N is the number of observation, total number of observation, not in each of the group, total number of observations. K is the number of groups, and H is the test statistic. We should be able to get the eta square for H. And cutoffs remain the same as the eta square, 0.01, 0.06, and 0.14. Now, the next research question is, are the levels of anxiety and depression similar between the groups? So what do you mean by, we have already compared one anxiety and depression, right? What is this levels of anxiety? When you say levels of anxiety, it could be a categorized variable. So here they are put as abnormal, borderline, and normal. categorical data. Groups are also categorical. So we are going to now see the association between two categorical variables. So we'll be doing a chi-square test. These are the assumptions for chi-square. So the last assumption is quite important. I will explain when we are seeing an output. So in the data, we have anxiety and depression, the levels here, and the score was also here. We have the two groups here. So we'll do a chi-square test. We get an output like this. Can you see that anxiety categorized data? And this is a group, yoga, non-yoga. And the chi-square test results are here. And this is the assumption. Expected value should be more than or equal to 5 in at least 80% of the cells. And no cell should have an expected count less than 1. Okay, now we will look from the output, what are we getting? So we are seeing that 33% of the cells have expected count less than 5. Now I will not go into the details of what is this expected value. More details. Expected value means values that are expected if there is no association between the two variables, or if there is no difference between the yoga and non-yoga group with respect to the anxiety level. Okay, so that is the value what we calculate. So if there is no, so I will just show you. So this is a negative thing for us. We are not meeting the assumption. This is okay. The minimum expected count is 4.5. That is okay because we don't have any value less than 1. So with respect to this point, it is fine. Now we look at another table where I have the expected value also shown there. So what do you mean by this expected value? Okay. So when you say here, if there is no difference in the anxiety levels between yoga and non-yoga group, we would expect around 14 people in each of these group. In the yoga group, for 13.5, when you round it off, it becomes, because there are totally 27 people who have normal anxiety level. Half of them would be in the yoga group, half will be in the non-yoga group. That is why it is coming as 13.5. Is all of you are with me? 27 people with normal anxiety level. If there is no difference in the anxiety between the two groups, half would be in the yoga group, half would be in the non-yoga group. Similarly, 9, here it is 4.5, 4.5. So this is the expected count. So I just examine to this cell. I can see that there are only 2 cells that have expected count less than 5. Right? But the problem here is when you look at the overall data, can you come back to this table? 45%, the first table itself on your left side, 45%, 15%, and 40%. So there is some skewness in the data distribution, right? Very less number of people who are borderline anxiety level in the analysis. So that is the reason why our assumption is violated here. So what should I do now? Can I just ignore? Because these expected values are, when you round it off, it becomes 5. So maybe I can ignore it and then report. Theoretically, sometimes we do that. Even though theoretically it says that only in 20% of the cells it can be lesser than 5%. It's lesser than 5, but it has become 33%. You can look at the expected count and this is 5. But the problem here is the total number of people with borderline anxiety is very less in the data. Okay. So what should I do? I can think about collapsing the table. When I say collapsing the table, it means combining the categories. Just okay. So we only have 9 people. So how do we collapse this table? I'll just show you how to do that. This is the original data. What I have done is now I have combined normal and borderline people. And I've done the chi-square. So the problem is solved. I don't have any cells with expected count less than 5. Assumption not violated. Now the question is, can normal subjects and borderline subjects be combined for the sake of comparison? Or the other way possible is, borderline is the problem. No, we only have 9 people. Can we combine borderline anxiety people and abnormal anxiety level people together? Even then, the chi-square test is done. That is also giving you a result without any problems. So is it possible to do? Which one should we do? Whether we should combine normal subjects with borderline subjects or borderline subjects with abnormal anxiety level. So it depends on the researcher. We should never combine categories just to get something significant. If it is logical to make an interpretation, we can collapse the category. So when you collapse, you might lose structure or meaning of the data. Sometimes it will create meaning. So now you only have normal and abnormal. It is easier for you to interpret maybe. But is it logical to combine? You have to mention this also in the text. Because of the skewed distribution or very less number of subjects in some of the categories, they were clubbed, and further analysis were done with the collapsed table or categorized data. So there are no hard and fast rules on how we should collapse. It depends on you, but people should not do this collapsing just to get the p-value significant or something significant to make it as a non-significant finding. All of you are with me? Any doubts? So we'll just see the depression results also. Depression, and in the 2 categories, we have the chi-square values. Now it is heavily violated the assumptions. 67% of the cells. We have 3 rows and 2 columns. So 3 into 2, 6 cells are there. In that, 4 cells have expected count less than 5. We will look into the expected count. See, the expected counts are very, very less. It's only 2. The problem here is, when you look into this data, majority of the subjects in the study have abnormal depression level, 87%. The remaining 13% of the people have been into 2 different categories. 7% of them have normal and 7% have borderline. So can you do any comparison where we have 7 people here, 7 people in another group, and 87 people in the other group? We cannot make any comparison, right? Or will you do any competition? Anyway, we know where there is majority, they will only win, right? We don't have to make any competition among the 3 groups. So it is not logical to make a comparison. So in such situations, we should not report the chi-square test results. We can just report the number and percentage. Now, this is the table structure. Can you see the difference? Even for independent sample t-test, Mann-Whitney, we use the same structure. Non-yoga, yoga, the 2 groups, number, everything same. Here we are going to represent number and percentage. And the test statistic here is chi-square value, this and the p-value. So we'll be representing anxiety, 3 categories, normal, borderline, abnormal. We are representing number and the percentage. Right? And which percentage is this? Which way will it add up to 100? Column wise percentage, right? So we can also, I forgot to add that in the as a footnote, that also can be specified, saying that it is a column wise percentage that has been used. And even though I mentioned for anxiety, we should not report the chi-square test, I used it here just to show the effect size calculation. Depression, we should not report. We can just say that chi-square test was not done due to low expected cell counts in some of the categories. Is that clear? Any comments, any charts? Okay, so as I mentioned here, this should not have been reported, but I reported just to show the effect size calculation. So effect size from SPSS, we can get phi coefficient, which will give you a measure of the effect size. We can also calculate something called as a W, measure W, that is chi-square value divided by the number, total number, and then take the square root. Both the phi and the W has the cutoffs in this. You will get phi coefficient also ranges from 0 to 1. The W also ranges from 0 to 1. 0.1, 0.3 and 0.5 are the cutoff for effect size. Is that clear? So here, this chi-square test, actually we were comparing the distribution of variables between the two groups, yoga and non-yoga group. Again, I have not put the degrees of freedom here. It is very clear what the degrees of freedom is. 3 rows and 2 columns. Degrees of freedom for a chi-square test is number of row minus 1 into number of column minus 1. Since all rows and columns are given here, we don't have to give the degrees of freedom. Now there's one more question where I want to show the analysis of chi-square test. It's already 8:15. When should I stop? Maybe after this test I can stop.
Yes, ma'am.
The class is till 8 o'clock, no?
It's okay. We can go up to 7:30.
Get till 8:30, sir, or 8:20?
8:30, ma'am. 8:30.
8:30. Okay. Okay. So are the levels of anxiety and depression associated? So here they have not mentioned anything in the question, in the research question, whether we need to do that in the yoga group or the non-yoga group. So since nothing is mentioned, we will use both the groups. And anxiety level and depression level are categorical data. And association between two categorical variables, we'll be using chi-square test again here. We have seen the assumptions already. So can we see here earlier we had on the column, we had the grouping. Now we have two variables here. So generally when you do chi-square test, we give a dependent variable or the outcome variable in the column. Now here anxiety and depression, which is the dependent variable, which is the cause variable. So we cannot specify that. You can give any manner, depression on the row or column, or anxiety also, vice versa you can do. Now this table has, we cannot report the chi-square value because it has violated. So you look for this percentage. If it is exceeding 20%, we should not report the chi-square value. We have to combine some of the categories. So here we have 3 rows and 3 columns. So either we have to combine the categories of row or we have to combine the categories of column. Now from our experience, we can see that the problem is here with the column. Normal depression, borderline depression, the number of people are very less. Even if you combine, you might not be able to get something feasible to do a test. Okay, so when we have this kind of data, we can calculate the percentage with column-wise percentage, or we can calculate row-wise percentage. Whether you calculate row-wise or column-wise percentage, your p-value, chi-square value, everything will be same. Say for this particular cell, how do we interpret this? We say majority of the subjects with normal level of depression have normal level of anxiety, that is 3 out of 4. For the same cell, when you use a row-wise percentage, we will be saying among people with normal levels of anxiety, only 11% had normal level of depression. So same number, but the way the percentage is calculated, the way you write or way you interpret will be different. So choose row-wise or column percentage depending on where you want to give the emphasis. If you want to, and your anxiety is on the row, you want to give emphasis to anxiety and say among normal levels of anxiety, majority had abnormal depression. That way, then you have to use a row-wise percentage. Is that clear? So two different ways in which we can describe the data, row-wise or column-wise percentage. How do you put it into a table format? We have now depression, we have 3 columns. Anxiety, we have got 3 rows, number and percentage. Now, which percentage you have put? That has to come in a footnote, column-wise percentages. And chi-square test was not done due to low number of cell counts. Suppose I have also done for gender. So I can add that as a next row in the table, mentioning the number again here. The numbers are very less. I think there is some mistake in the number here. It should be 12. Female should be 12. Okay, so because we have got 3 columns and the 2 columns, the 2 groups, numbers are very, very less. We will not be able to do a chi-square in this particular example. But just to give you an idea about how to represent the chi-square test. Is that clear? Now we are moving on to correlation. Does anxiety lead to depression or whether they are correlated? Now, both anxiety and depression are numerical. Groups are not specified, so we'll use a combined data itself. So the assumptions are that both variables are numerical, they have a linear relationship, and they both should be normally distributed. So before doing a correlation, as I mentioned, we have to check the assumptions. Whether it is normally distributed, we can visually inspect. Not normally distributed, not a linear relationship. We'll have to also check whether anxiety and depression are normally distributed. But here, since they are not linearly related, I can go in for Spearman's correlation. So I've just shown you a simple scenario where 2 variables are correlated. We have the diagonal elements as the self-correlation. First cell will be anxiety into anxiety. This will be anxiety into depression. This is depression into anxiety. This will be depression into depression. So self-correlations are the diagonal elements. Above and below the diagonal, off-diagonal elements are mirror images. So when you are making the table, either you can just keep I'll just show you in the next slide. This is one format where I say the variables and then correlation with depression, Spearman's correlation, bracket, we have the p-value. And for correlation coefficient, the effect size is also the correlation coefficient. R itself is a correlation coefficient. We have the benchmark of 0.1, 0.3, and 0.5, which we have earlier seen for Mann-Whitney U. We calculated R, no? 0.1, 0.3, 0.5 were the cutoff. Otherwise, we can take square of the correlation coefficient, that is R square, coefficient of determination, that also can be used as a effect size. Any comments, any queries? Okay, so if I add one more variable, so if you have more variables, your tables will become more bigger. You get too many numbers. Those who are not used to seeing the outputs will get scared seeing the output. So what we need to do is we draw a line to see the diagonal elements or the self-correlation, and above and below are the mirror images. We can put the results here, p-value, correlation coefficient, and the p-value here. Another way to put is, don't give the p-value, we can just give a star here. I forgot to remove this p-value from the title. We can just give a star here and give a footnote here saying that it is significant. But this is not a good way of representing, because the reader has to see the p-value to take an informed decision, right? Whether the correlation is significant or not, it is better to report the p-values. And also you need to report the number. Can you see why I put number as 55 here? Sometimes the correlation between in each of these cells, you can see the numbers in the SPSS output. Here in the data, nothing was missing because it is completely simulated data. In real life data, some people forget to even tick maybe or enter age, or they might not fill up all the depression scores. So total score might not be there. So when you say if age is not there for 5 people, but depression is there for all 60, the correlation will be calculated only for the 55 subjects who have both the information. That is why I put anxiety as 60, whereas age, the number can be different, right? So number has to be mentioned. Why that is important for correlation is, as the number increases, even a minute correlation, even though it is not very strong correlation, it can become significant. So the reader should be able to understand that. You would have seen many times 0.131 is a correlation. P-value is 0.001. Recently, I've analyzed one study. The sample size was 1,200. A study done on school children about internet addiction. Internet addiction and self-esteem or something, the correlation is negative 0.131. Very, very minute correlations, almost equal to the zero. Zero, and this is 0.1. Zero is the lowest. And 0.13, negative, but highly significant, 0.001. That's only because of the number. That is why important to specify the number. Now, it could be that in some data, all data is complete. The number will remain 60 for all the rows. Some variables, they will be missing data. In that case, the number here also in the SPSS output also, number will be different. That we need to mention here in the table. Is that clear? This is another way of representing. This I got from the internet. 1, 2, 3, 4, 5 variables are there. 5 by 5 correlation matrix. They have not put the p-value. They have put all the correlation coefficients here. Okay, so we don't know which of these are significant. I can just put the diagonal elements. So it becomes very congested, like too many numbers. Mirror image. So there is another format or another way of representing this. Here again, we have got 6 variables. They have not put the names on the columns. They have given the number here 1, 2, 3, 4, 5, 6. So they have only used the numbers on the column heading, and the self correlations have been highlighted with the hyphen, and the mirror image, all values are not shown. Only one set of values are shown. So there is no hard and fast rule as to only below the diagonal has to be shown. You can even show above the diagonal, there is nothing wrong. But again, here, the significant ones are not highlighted. If all the correlations are significant, you can just give a footnote saying that all correlations were significant. You don't have to give star for each and every value. But if some are significant, some are not significant, you have to highlight either the significant ones or the non-significant ones. And in research, we always look for significant correlation. So it is better to highlight the significance one by adding a star here. Or use the other format. Instead of making the table like this, go for this format where you can give the p-value and the correlation coefficient. Depending on the number of variables we have, depending on the complexity, always keep the reader in mind whether they will be able to understand what the results are. Any comments in the chat? No comments. Okay, so next we will see another research question. Is there any difference between baseline and post-course of anxiety and depression? So we are now going to compare the pre and post scores. So we'll be using a paired t-test. Again, since it is not mentioned in which group, we'll be using the combined data of 60. This is how the SPSS will give you an output. You have about 4 tables. The last table is effect size, and correlation table also will be given. We will not need correlation when we are comparing the means. So I've edited here, kept only the ones which we need here. Statistics, that is the descriptive statistics, test, and the effect size. Again, effect size, we'll have Cohen's d and Hedges g, both will be given. Any one of it is required. Most commonly used is Cohen's d. The slight difference between Cohen's d and Hedges g, it is written here as a footnote on the left side table. Okay, so what is the conclusion? We have the p-values less than 0.001. It means the pre and post differences are highly significant, right? So we will now convert that 3 tables into a table format. Table structure remains the same as that of a independent sample t-test. Only thing is that these column headings have changed. Earlier it was 2 groups, now it is the 2 repeated assessment. And I have not given the number here. Pre, how many were there, post, how many were there, that does not matter, because when you look at this pairwise comparison result, if both the data are there, only then we will be able to do the test. So both will be 60. So where we will be mentioning the number is when you are measuring the parameter. Anxiety, 60 subjects, pre and post mean and standard deviation, t-value and the p-value. And we can also report the Cohen's d effect sizes. We give a footnote as what is significant. And these are the cutoffs. So these values are very large effects. Now here I have done this comparison for the entire subjects. So when we have 2 groups, it is not right to do that combining the groups, right? One group has received intervention, the other group has not received the intervention. It is not fair to combine both the groups and do the analysis. It is better to do that separately. So if I want to see that, is there any difference between baseline and post-test scores of anxiety and depression in experimental and control group? Then I have to do something called as repeated measures analysis of variance. Even though we only have 2 time points, 2 repeated assessments, but we have 2 groups of data. So instead of repeating the paired t-test 2 times, it is better to go in for repeated measures analysis of variance. Little more complex assumptions. More important assumption is the assumption of sphericity. I'll explain that separately in a slide. Sphericity means equality of variance between pairs of serial measurement. I'll show you our data. See, now we have HMSC score measured at baseline, 2nd month and 4th month. So we need to calculate the difference between baseline and 2 months. 27 minus 27, the difference is 0. Similarly, next serial pair, difference between second month and 4th month. 2nd time point and 4th time point. So 27 minus 30, the difference is 3. Depending on how you are calculating, 30 minus 27 is 3. Have you understood? So we calculate the serial differences. 0 to 2, 2 to 4. We don't calculate 0 and 4. That is not a serial consecutive data points. No? So then we check whether these differences are normally distributed. And the assumption is that for difference 0 and 2 and difference 2 and 4, the variances are similar. That is an important assumption in repeated measures. So there is not very drastic change at different time points. People are going to change in a phased manner. Variances of the group of people, the variances are similar, is the assumption. Can you all just read this points on the slide? Equality of variance between all pairs of serial measurements. So we can test this assumption only when we have 3 time points or more. If we have only pre and post, there is only one difference, right? We cannot check whether the variance of this is different than that. So minimum there should be 3 time points to check this assumption. This is similar to our equality of variance, but in a related data, dependent data situation. So when you go in for repeated measures analysis, again, there are too many outputs. I have just pasted whatever is required. We have the descriptive statistics, test of within subject effect, and test of between subject effect. So under that, we have the p-value here, and the effect size is partial eta square. So from this, we are able to see the interaction effect. This is factor 1 is usually the effect of time. Is there any difference between pre and post, anxiety pre and post? And this is the interaction effect. And the next table, test of between subject effect, group. This line will give you the p-value for the group differences. Okay, we can understand this easily by looking into the graph profile plot. So there is a difference from pre to post. Can you see that? 1 and 2 are pre and post. I did not label it. 1 is pre, 2 is post. The two groups are changing from pre to post. But there is no difference between the two groups. Group wise, there is no difference. The anxiety is similar in the yoga and non-yoga group. And the way the scores have changed is also similar. So we say there is no interaction.
We are running out of time, so
Yeah, I'm just
probably
completing with this. So how do we report? I'll just show the table. It will be quite confusing in the initial stage. Anxiety, you have the non-yoga and the yoga group, mean and SD. We'll have 3 F values and 3 P values here. Between group, within group, or that is a time effect and the interaction effect. And we have to report the effect size also for all the 3. So effect size here is a partial eta square. Okay, if you are comparing depression, that has to be a separate analysis. The result also can be put it into a same table in the similar manner. I'll stop here.
Ma'am, one last regression. One of them, not all.
Yeah, I'll
Not
just
the
show
regression.
you the,
How to present. Just the table.
Yeah.
How should it look like?
Yeah. This is the output. And I have just highlighted what all information we need to take from this output to make a table. So we need B value, that is the regression coefficient. B is unstandardized coefficient. Beta is the standardized coefficient. Either B or beta, anyone should be enough. But most of the people give both B and beta together. And the T value to see the significance of that, and the P value. We also have to report this F value to see if the model is significant, and the R square values. I think it should be self-explanatory because I've highlighted what we need. The dependent variable, when you see an output, you will be able to see whether what is the dependent variable by looking into the footnote of the table. Each of the table will have that footnote. This is for linear regression. Again, here some variables which are non-significant also have entered into the regression because they have used ender method, where we are forcefully entering all the variables to be part of the regression. We should use either a forward or backward method or use a stepwise method. You will get only the significant ones. This is an example similarly for a logistic regression. We have to use the R square values. We can get the accuracy of the model from this table, and the odds ratio, confidence interval, and the p-value. This is what we need to be presented. So this is again a model adequacy test, chi-square test. That value also be rotated. R square value to be reported. This is a sensitivity, specificity, and the overall accuracy rate. Sensitivity, this table is a classification table, just to explain. On the row, we have the observed data. On the column, we have the predicted data, predicted by logistic regression. So if you look at this particular row, we have 65 people in that. 55 of them have been correctly predicted. So 55 divided by 65 is 84.6. So that is the specificity. Among people without the disease, 85% of them have been correctly predicted as not having the disease. That is the specificity of the model. Sensitivity is only 46, and the overall accuracy is 71%. That also has to be reported in the table. Most of the time when people report, they only report the odds ratio and confidence interval and the p-value. They don't report the model adequacy, the chi-square test, R square value, or the overall accuracy of the data. Now here again we can see the confidence interval is very wide. We have to also specify which category this is. Gender, there are two categories, male and female. So in logistic regression, one will be a reference category. So we'll be talking about female, the risk for females or males. So instead of giving it as one, you should also mention it as male or female. But this I could not run from the existing data, so I have used data from SPSS layered statistics. So I did not know whether it is male or female as the reference category. But it is better to mention. The other three variables are numerical. So age, weight, VO2 marks are numerical variables. There's one you need to specify whether it is male or female you are talking about. There's one more example about. So how do you know which is the reference category? If both are given the dummy coding of 0, it means this is the reference category. So from the output itself, we should be able to understand which is the reference category. So and we also can see whether we have sufficient number of subjects in each of the category to go in for the logistic regression. So what is required is the chi-square, R square, the accuracy, and the confidence interval and odds ratio to be put it into a table format like this.
Subhashini.
Thank you so much, ma'am, for spending so much time. I think we all understood how to present tables for a chi-square test, for a independent sample t-test, for a paired sample t-test, and man-Whitney U test, ANOVA and Kruskal-Wallis, and also the regression, both linear and logistic regression, and also the correlation, and also repeated measures. So it was a very exhaustive and informative presentation, and there were also a lot of new information which I could get, especially how to calculate the effect sizes for a man-Whitney U test, and the Kruskal-Wallis for the non-parametric test, how to calculate the effect size. So that was new to me, and I think everybody would have learned a lot from this session. We don't have any questions on the chat.
Can I
So
ask
I
one?
think in the interest of time, people need to go. Already people start
Yeah,
leaving, so we can wind up and we can
yeah.
always come back. Mariyamma is our team member, so we can always rearrange and reorganize.
I know it would have been quite difficult because you need some time to understand all these things. I will correct the mistakes and share the PPT as PPT itself so that it is easier to follow than the PDF.
For those of you who want more statistics, who want to learn more statistics, I think Professor Mariyamma is running a course in third week of January. So please contact me or Dr. Mariyamma directly for more information. So I think
It's advertised on our website. The brochure is there, the registration form link, everything is there.
yeah, right.
Thank you.
So I think
Uh,
Subhashini, any final comments? You have done already. Okay, Apurva.
Yes, sir.
no.
So, any final questions or comments by anyone? Ranganath sir, would you want to say something?
Ma'am, excellent session, ma'am. Very informative. Uh, as always, you have been a delightful speaker. I have one question. Looking at as a peer reviewer, looking at the logistic regression table, if the authors have provided only odds ratio and 95% confidence interval, will it be fine? Because sometimes the odds ratio might be very huge and authors might have just presented logistic regression instead of fixed generalized logistic regressions. So based upon just odds ratio, can we make out whether this logistic regression table is right as per the statistical assumptions, or should it have been corrected for its analyzed logistic regression? Any comments on
Yeah,
that?
sir, we'll have to look into first confidence interval for odds ratio. If the interval is very wide, it means that there could be multiple problems. One could be multicollinearity issue. Two variables could be highly correlated to each other, or the numbers are very less in some of the categories if it is a categorical variable, right? So there are multiple reasons. So we need to examine the data to see. So that's why I mentioned in the beginning itself. First, before going into logistic regression, do you have sufficient number of people in both the groups to make a comparison? 80 people in one group and 20 people in the other group. Can we do a regression? Should we do a regression? That kind of a decision we have to make before going into that. So highly skewed data, we should not be using a logistic regression. As you have messaged Dr. Subhashini, whether fifth logistic regression to be used when you have highly skewed, the prevalence is very less. So naturally, people with the disease, number of cases would be very less. So we will have to use a different regression technique itself. And highly correlated variables. The variables are highly correlated. We should not use a logistic regression. So just by looking into an odds ratio, we will not be able to understand, but we should ask for the summary statistics, model diagnostics, whether you have the Hosmer and Lemeshow chi-square value, test value, chi-square result, the accuracy levels, all this also should be provided.
AIC and BIC, are they must in logistic regression or anyone is okay? Occasionally,
I didn't get you, sir.
AIC and BIC.
AIC and BIC
I can
values
see the
also can be
information
obtained.
available.
Yes, from the logistic regression, we can get the AIC and BIC values also.
They have to be present in the table.
If it is only a single model, because AIC values, we need to compare between models, we use
Between
that.
models. Yes.
Between the models to find out which model is better, then we use AIC. But here it is a single model, right?
Yes.
Say when you say multiple models, say for example, I use 5 variables as model 1. I use 7 variables as model 2. And I want to compare which is giving me better results. So then I should use AIC value, AIC or BIC for comparison.
Okay, sure. Thank you.
Yeah.
Okay. Thank you, ma'am. Thank you, Ranganath sir. Thank you, Mariyamma ma'am, once more for letting us through this really difficult journey of statistics and how to put it in the results. Thank you, Subhashini ma'am. I don't think there could have been a better moderator apart other than you who could do this so seamlessly, because you had some understanding of stats also, and the moderation was really nice. So thank you, ma'am. I think there are a lot of requests on people asking for the slides and the video recording. So I put it in the chat box about when, like at the link where video recording would be available. So thank you, ma'am. Thank you, Subhashini ma'am. Thank you, all the participants, for being here till now. Ravindra sir, would you want to give final closing remarks?
Ma'am, slides would be useful if it's possible.
Yeah, I will edit and I'll send it to you by tomorrow, sir.
Yeah, sure. Thanks.
Sure. Thank you, ma'am. Sir, I think Ravindra sir is not available. So would it be okay if we wind up?
Yeah. Okay.
So
Thank
thank
you,
you all.
ma'am.
Thank you,
Thank you.
everyone.
Thank you.
Thank you, ma'am. Thanks a lot for the session, and thanks to Vijay
Thank you,
sir
Dr. Subhashini.
to moderate.
Right. Thank
Sure.
you all,
Okay.
and good night, everyone.
Thank you.